Hi, welcome back. Let's continue, shall we? So last time I was trying to texture a triangle and I got pretty far along, but not perfect. So if you see here, I got a texture on a triangle, but it's supposed to be green, blue, blue, green, and a texture pattern. And just glancing at the code before the stream, I noticed that I had something wrong. Right here. So basically the system pitch is how many bytes are in one row of my texture, not how many pixels. And I was putting numbers as if I was putting how many pixels, but it's supposed to be bytes. 1, 2, 3, 4, 5, 6, 7, 8. So just by changing that to 8, I should get the right color pattern. Oh no, that didn't work. Oh, well, it'd help if I recompiled, right? There we go. So now we got the green, blue, blue-green checkered pattern that I was looking for. Okay, so now the next thing I want to do is fix my sampler. I don't want to take in a sampler. I don't want to hard code the sampler basically in my shader. I want to pass it to the shader from the CPU. So, all right, so I need to make a sampler descriptor or something like that. I don't know, let's look it up. All right, sampler state. There we go, sampler descriptor. All right, so I know I need to make one of these. I think it's just D3D11 sampler descriptor. Yeah. Okay. There we go. Sorry, webcam crapped out. All right. Where was I? Okay, so I was trying to figure out how to fill out a sampler descriptor. Is it just C3? There we go. This is what I was looking for. No, maybe not. There we go. That is definitely what I was looking for. Okay, yeah, so once I get my sampler descriptor, I can fill out all the members of it to do what I would like. All right, so the filter is, there we go. All right, so let's look at what our filter options are. So yeah, I just want it to be a point. I want rigid lines in my texture. All right, and then this is going to actually, let me just go ahead and knock all that out at once. There we go. Okay, so then the address, the mipping, I believe is what they call that. No, that's not mipping. Okay, so I just want to clamp to the edge if it goes beyond, which I don't intend to make the coordinates, the texture coordinates go beyond the edge of the model. So that shouldn't really affect me. The mid level of detail bias. All right, so the MIP, okay, so offset from the calculated MIP level, mipmap level, for example, of Direct 3D calculates that a texture should be sampled at mipmap level 3, bias 2, then structure will be sampled at mipmap level 5. Okay, I don't really, let's just leave that out for now. Max anisotropy. Clamping value used if this or this is specified in filter. Well, it's not, so I think I can just leave that out. The comparison func, I don't think I need that at all, so I'm just going to put never for now. The border color, I think I could leave that out. The min level of detail. So the lower end, where 0 is the largest, sure, 0. And then the max, yeah, let's use the max float. All right, so we got our sampler descriptor. But I believe I still need to make a sampler state. Do they give me any? Yeah, okay, so yeah. Okay, so I gotta make a sampler state, and then I can create my sampler. All right, then all right, so that's going to be called using my D3D11 context. No, that's not context, the device. And then I'm going to pass in my sampler descriptor and my sampler state. And I believe I need the address of both of those. So let's, huzzah. And 195, yeah, I got a stray closing parenthesis. There we go. All right, nothing's changed because I need to actually tell my pixel shader to set the sampler state, or set samplers. There we go, and then that's also, not also, but that's going to be done through using my D3D11 context. And set samplers. Okay, so I am going to start at start 0. I'm only setting one sampler, and the actual sampler that I am setting it to is, let's just rename that to sampler state. Bam. Uh-oh. Oh yeah, because that should also be sampler state. Right, so, oh, and I need to tell it that it's the address of that. There we go. And we got clear-cut pixel lines in our triangle. Yay, okay, so that, basically that's where I wanted to get last time, but that's not where I did get. So, yeah, so let's move on from here. So what I want to do now is be able to modify my triangle using a constant buffer. Okay, so I need to make a constant buffer, which is basically things that the CPU sets, like states that the CPU sets, and then passes over to the GPU and says, hey, these are the value of these things. perfect explanation. I know you should all be experts on what a constant buffer is now. So the way I make a constant buffer in HLSO is using this C buffer, which I treat it just like a struct, like a data structure of some sort. But the C buffer keyword, I assume, just lets it know that it's going to come from a buffer register. So I'll call this vertex constants. And all I want to be able to do is pass in a matrix, a 4x4 matrix. So I'm going to use a float 4x4, 4x4, and I will call this transform matrix. All right. Yeah, I'm not going to change anything else for now because I want to be able to make my constant buffer. And it's more or less the same principle as making my vertex buffer and my index buffer. In fact, as far as I know, I can copy and paste and then just modify what I need. So I'm just going to copy everything I'm doing for my index buffer and then just modify it to be a constant buffer. So first thing I need to do is actually make something to pass into my shader that will modify my triangle. So I need a matrix, a 4x4 matrix, which is more or less just a array, right? So I'm going to have float, I'll call this transform matrix, and it's an array, and I'm just going to initialize it to an identity matrix, right? So that's just 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and then 0, 0, 0, 1. All right, so I just got ones along the main diagonal. That's the identity matrix. In matrix speak, that is basically the number 1. All right, so let's change this. So I'm going to call this const buff descriptor, and that's going to be the size of my transform matrix. And I need D3D11 bind constant buffer. All right, and the source data is, let's call this const buff data. And then that is going to point to my transform matrix. And so I need a ID311 buffer. We'll call this, I'll call this vertex const buffer. And so I want to create the buffer. I'm going to pass in the constant buffer descriptor. No, hold on. Yeah, there we go. Constant buffer descriptor. I need to pass in the constant buffer data and then the actual constant buffer itself. And then we'll just say that this is, if that doesn't work, it's an error creating the constant buffer. All right, and then so we're using the context, and then I believe I want to do ps set index, no. Okay, so I need to look this up here. ps set constant buffers, no, vs, because I'm setting the constant buffer of the vertex shader, not the pixel shader. There we go. Okay, so the start slot, the number of buffers, and then the actual buffers. Okay, so let's go back to vs set constant, and it's buffers plural. And so I'm going to pass in, I want it to start at 0. I want 1 buffer and the actual constant buffer itself, which is called vertex const buffer. Compile, I get errors because cannot, oh yeah, because I need to pass in the address of that pointer. And when I run it, nothing changes, but we can easily test to see if it's working by, all right, so here's my transform matrix, and if I'm not mistaken, I can just use that directly here in my vertex shader, and I want to multiply that by my position. And if this were OpenGL or Metal, I can just multiply like that, but DirectX is not like that, or HLSL I should say. So I have to use this function called mul, the multiply function, that actually multiplies two matrices. And what's dumb is like if it's a vertex, like if it's like a 3D vector or a 4D vector or 2D vector, whatever, I could just use the multiplication symbol. But for matrices, they built in this function. You have to use this function for some reason. I don't know. Just a minor nitpick. All right, so I got my triangle, which is a good sign. So now to see if my constant buffer is working, I'm going to modify my identity matrix, because right now it's basically just the one. It's like whatever I multiply this by is going to just get that back. So if I modify this, this is the x, or sorry, this is the width of my triangle. So if I do 0.5, it should be half as wide as it was before. And if everything's working, which I suspect it to be, yes, there we go. It's half as wide. And then just for emphasis, let's shrink the y coordinate, the height of it by half. And yeah, now I got a smaller triangle. I am transforming my triangle. That is good. That is what I wanted to get done. All right, so let's go back to the identity matrix. So now what I would like to do is make a perspective. Like I want to be able to look at my triangle from any point in space as if I'm just a human walking around it. So to do that, I need to create a perspective matrix. But in order for that to do anything, I actually have to take my triangle out of 2D space and put it in 3D space, which basically means I want to add a third point to the position of my triangle. Right, so for now it's just going to be 0. It's not going to be any visually different, but it will allow me to later on do the proper mathematics involved to give it the perspective that I want to be able to move around my triangle. All right, so because I changed this to now be a 3D point, I now need to modify a bunch of other things. So first off, my position is now not just an R and G coordinate, but it also has a B coordinate, or a Z coordinate to be proper. All right, and now my offset from my texture coordinates is now going to multiply the size of a float times 3. And that's going to be the same. And I believe I needed to change my stride, because now in between each set of vertices is no longer 4 floats, but it's 5 floats. And one more thing is in my vertex shader, I want to change the position to be a float 2 to a float 3. And here where I am taking the position, I don't need to provide the Z coordinate anymore because it's now a part of the position. So once I do that and compile it, I should have nothing changed, which means that it's good, it's working. So now that I have that Z component as part of my triangle, I can do the proper mathematics involved to move my thing around, my camera, my quote-unquote camera around the triangle. All right, but I don't actually have a camera. I just have a, oh no, not that. There. This, for all intents and purposes, is my camera at the moment. But I would like to formalize this a little bit. And to do that, I would like to make a library that has some built-in mathematics. I like to say mathematics because then it pisses, then I'm not pissing people off by, because you get the people, it's maths. It's not math, it's maths. But if you say the whole word, then nobody can complain, right? Okay, so anyway, I'm going to create a new file. I am going to call, you know what I'm going to do first? Before I create my mathematics library, I'm going to create a small utilities.h. And what this is going to do, it's going to have various things in it later, I'm sure. But what I want to do is I'm going to be using a lot of unsigned variables. And I I don't like to have to write the word unsigned a lot. Not only is it hard to spell with all the silent letters, but it's just too space consuming horizontally. If I want to specify that a variable or a data type is unsigned, I would just like to do it with one letter. Okay, so I'm going to make a few type defines that just make it easier for me to type basic data types. So I'm I gotta remember how to do this. Okay, so I think it's type def, and then I put what I want to call it. So for example, U8, and then this is going to, then I put what it actually represents. So this is going to be an unsigned, wait, how do I spell it? See, I can't even spell it. Unsigned, there we go, char. Is that right? And then let's say if I say U8 taco equals 5. Is that good? All right, so let's actually, I want to include all of my libraries prior to including the system libraries. Utilities.h. All right, so cannot include file utilities.h. No, did I misspell it? Utilities. Oh, yeah. There we go. Okay, so unsigned char should be preceded by semicolon. Okay, so maybe I got this backwards. I think you have to put the type you're defining it as and then what you want to call it. So, missing semicolon before you don't know. Or do I have to end it with a semicolon? Yeah, there we go. Okay, so type define unsigned char, type def unsigned short is going to be S16, nope, U16. Type def unsigned int is going to be a U32, and type def unsigned long. 64 bits in that. Okay, so then I need the signed versions of all that. Type def char is a, I'm going to say that's a signed 8, S8. Type def short is S16. Type def int is an S32. Type def long. Okay, so those are all the integer types, and then I need my floating type, my floating points. Type def float. Yeah, I'm going to just call that F32. And then if I need to make a double, I would like to refer that as a F64. Okay, so I think that's good for now. Let me just triple check and make sure that that all works. So if I were to come down here and replace that with F32, are you happy? No, you're not. Okay, so undeclared identifier, that's on utilities.h. Oh, because I don't need the equal sign. What was that all about? There we go. You're happy, still get my ugly triangle, great. All right, cool. Okie dokie. All right, so now that I got that out of the way, I can now start on my is it M-E-T-H-E? I've actually never typed out the word mathematics. Math, yeah, it is with an E. Assuming that the autocomplete is correct. Okay, anyway, so that's going to be mathematics.h. Okay, so first thing I need, well, yeah, first thing I need immediately is a matrix. So I'm going to use a union for that because really a matrix is just 16 floats, and however else I want to refer to those floats, I don't need to like create more space to identify it as such. So I'm going to call it matrix 4 so that I know it's a 4 by 4 matrix. And let's say it's going to have, I also want this to include my utilities. So that way I can use my abbreviated data types. All right, so it's got a F32, we'll call this M. It's got 16 of those, all right? And then since it's a union, if I were to make a 2D version, so let's call this M2 of 4 by 4, it's all gonna take up the same space, same amount of space. So, all right, cool. All right, so all right, so since mathematics is including utilities, I don't need to include that explicitly. I can just include mathematics. And you fail to compile because I probably misspelled something. And I did. There we go. All right, so now that I'm including my mathematics, let us replace this transform matrix as a float array with one of my matrices. All right. And then what I would like to do is make a function that generates a identity matrix. So it will return a matrix 4. It could just be static, by the way. I don't need it to do anything local. So matrix 4, it will be called create identity matrix. Don't need any parameters for that. And all it's going to do is make a new matrix 4. M.M 0. Oh, wait, am I going to have to do this? What if I put a constructor in there? I don't want to do that though. Yeah, okay. There's probably a better way to do this, but I'm just going to actually go variable by variable, element by element. All right. Okay, so then that's going to be 6, and that's going to be 10, and then that is going to be 14. That should be 15, that should be 11, and that should be 7, and then that should be 1. Okay, so just to double check, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Okay, and then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. All right, so let us see if that works. So this transform matrix is going to be equal to the creating of an identity matrix. And when I run it, I get errors because it's not creating, it's create. And I get an error. Cannot convert from matrix 4 to const void pointer. What are you talking about? Oh, because I need to point or put that at the address of that, I believe. Not all paths return a value. Create identity matrix must return. Oh my goodness, yeah, duh. Yeah, so once I build the matrix, I have to return it. And we don't get the errors, and I still get my triangle. And just to see if things are working the way I would like, let us take my transform matrix and then take element 0 and set that to 0.5, and I should get a skinnier triangle, which I do. All right, and then let's test the ability to change the 2D array. So if I change the height at element 1, 1, does that also change my triangle? And it does. That is cool. That is great. All right. All right, so 2 more things I want to do, at least for now, is be able to build a perspective matrix so that I could look at my triangle in a similar way to the human eye. And then also be able to multiply matrices, because I'm going to take the position of my camera, the position of the triangle, and the projection matrix, and multiply them all together. And then that will make it look like I'm looking at my triangle through a human eye, and not on a flat 2D surface, at least hopefully. So let's go back to mathematics. What I'm going to do is I'm going to make a function that returns a matrix 4, and I'm going to call it create projection perspective. I'm going to call it create. So projection, because there's orthographic projection and then there's perspective projection. So I'm going to call this create perspective projection. Sure. And I need some parameters to define the type of projection I'm going to do. So I need a field of view, how wide of an angle I'm looking through. I need an aspect ratio. And then I need a z near, so how close the camera can see. And then I need a z far for how far away the camera is able to see. And so using that, I can build a projection matrix by simply cheating, going to the old Google box and typing in projection matrix. And I think there's a cool image somewhere that, like, oh wait, I can't even type. Okay, so perspective projection matrix, here we go. And then yeah, so this is it. This is the way to do it right here. Where did it go? All right, so I need basically this formula, and if I'm not mistaken, I need to transpose it. I want all of the rows to be columns and all the columns to be rows. So, oh shoot, I just realized I need a tangent function. Let's see. Yeah, tangent series. Is there a Taylor series for? The Malkirian, McLaren? Oh, that's McLaren. McLaren Coconut. Okay, for tonight, for today only, I am going to include math.h just so that I can use their tangent function. But then next time I'm going to replace that with something presumably slower for now, but eventually I'll replace it with something faster, but something that's made by me and not whoever wrote this. All right, yes, let's do away with that for now. So I want to use this here, okay? Yeah, so let's make a matrix M. I don't need to initialize it. So the m.m at 0 is 1 divided by the aspect ratio times the tangent of the field of view divided by 2. So 1 divided by aspect times the tangent of field of view divided by 2.0. And that should be it. And then m.m at 1 is 0. And then m.m at 4 is 0. And so now the next element is 1 divided by the tangent of the field of view divided by 2. So basically not multiplying it by the aspect ratio. Is 1 divided by tangent of the field of view divided by 2.0. And then 0, 0, 0. So I need one more 0. And so then, oh shoot, I forgot I was supposed to be transposing this, which doesn't matter for these two actually. But yeah, it doesn't matter for that. But this should go here and then, okay, so I just need to flip those two around. So I'm good. So the next part is the negative z far plus the z near divided by the z far minus the z near. Okay. Equals, so I need the negative of z far plus z near divided by z far minus z near. And so then this is flipped, so then the next element is negative 1. And 0, 0, and then that one. And then, okay, so then I need the 2 times, actually the negative of 2 times the far times the near divided by the far minus the near. Okay, so m.m at 14 is equal to the negative z far times z near divided by z far minus the z near. last one is just 0. All right, so that should be my perspective projection, I hope. We'll find out. Oh yeah, also don't make the same mistake as before. Once I built that up, I want to return what m is. All right, and now I need to multiply, be able to multiply a matrix with another matrix. Let's put that up here. All right, okay. Multiplying matrices, it's simple once you know how, but I can never remember off the top of my head. So it's basically take every column of one, or each element of a column of one, multiply it by each element of a row of the other, and then add that together, and then that's one element of the matrix you're trying to build, I guess. I don't know. Okay, so anyway, I need to make a matrix. That's the result. I'm eventually going to return that. Then I just need to build up what this matrix is. So the element at 0 is equal to, so m1 dot m2 at 0, 0 times m2 at 0, 0. All right, so that's 1. And then I don't need to worry about order of operations, I don't think. So then I'm going to add that to the m1 dot m2 at 1, 0 multiplied by m2 dot m2 at 0, 1, right? Yeah, okay. So m1 dot m2 at 2, 0 is going to multiply by the m2 dot m2 at 0, 2. Sure hope this is right. And then I'm going to add that with m1 dot m2 at 3, 0 with the m2 dot m2 of 0, 3. And that's it. That's one element of my new matrix. And I need to do that 15 more times. All right, so then the second element of my matrix is that one. So I'm taking, hold on. So I'm taking the second column of the first matrix and multiplying it by the first row. So 0, so I think that's 0, 1 for all of this. I basically want to just replace all of m1 second spot with 1. Oh, okay, I think so. And then, so these would be the third row, or sorry, third column. And then this should be the fourth column. All right, I am like 50% sure that is correct. All right, so that is the first row of my matrix. Now I need the second row of my matrix. So m.m at 4 is equal to, okay, so now I basically want everything from n1. No, that's not right. I feel like this isn't right at all, but it's so confusing. Okay, so yeah, so for this first one, it's going to be very similar to this one because the M1 column is the same, but M2 is now the second row. No, second column. All right, so I believe that's going to stay the same, and then M1 does all the same changes as previously. So that's going to be 0, 1, 1, 1, 2, 1, and 3, 1. So the next one is 2, 2, 2, 2. Okay. And then 3. 3. Okay. I don't know. Yeah, okay. So that's, something's not right. Maybe it is. All right. M at 8. All right, so now I want same as this one, except for M2 is now the third column. And then that is all going to change here. Oops, that's not what I want. Okay, so that's 0, 1, 2, 3, M1, 0, 1, 2, 3, M1, 0, 1, 2, 3, 0, 1, 2, tray. Okay. And, all right, so then again, more or less the same, except for I am now going on to the, what did I just do? Okay, so I'm going on to the third column of my second matrix. Let's go ahead and put those there. All right, and then 13, 14, 15. So M1 is going to go 0, 1, 2, 3. M1 is again going to go 0, 1, 2, 3. M1, 0, 1, 2, 3. And M1, 0, 1, 2, 3. Okay, I potentially made a matrix multiplication function. What I should do is test this with numbers instead of trying to just jump straight in and test it with my graphics, but nobody wants to do that. So let's make a new matrix here. Matrix for, I'll call this projection matrix. We'll call this create is it called create projection matrix? Create perspective projection matrix. Yeah, I'm missing, wait, how did that? Yeah, so I need the field of view, which for now I'm just going to use 70. My aspect ratio is f32 width divided by the f32 version of the height. My z nears is going to be 0.01, 001. And then my z far is going to be 1,000. Yeah, all right. Undeclared identifier. Mathematics line 20. Because that's a matrix 4. Still. M-A-T-R-I-X-4. M-A-T-R-I-X-4. What is going on here? So, oh, line 40, yeah. Matrix 4. There we go. Okay, everything runs, no errors there. Okay, so I'm actually going to call this the model matrix. So this is basically how my triangle is going to be affected. This is how I view the triangle. And then I'm going to make a third matrix that is called the transform matrix that is equal to the multiplication of my projection matrix first, and then the model matrix. Everything compiles, and when I run it, my triangle disappears, which is to be expected even if it were working, because I'm putting my camera essentially right on top of my triangle, and it's basically like inside the head of the person trying to view from. So to fix that, what I'm going to do is take my model matrix and then take the X position, which is the fourth row and the first column, I believe. Actually, no, not the X position, the Z position, so the third column. And I want to push it back. So to push it back, I believe I want to go negative. So let's just make that -5. And if everything's going well, I'll see my triangle looking like it's pushed back in the distance. And it is. Oh my God, I'm so excited about that. Oh my goodness. Okay, that is awesome. That is so cool. All right, wow, all right. I don't know if that's cool, but yeah, so okay, I'm gonna do this. I'm going to actually just take it from here, copy that. I'm gonna put this here in my loop, my main loop. And I'm gonna try to get it to look like my triangle is slowly moving further back. So to do that, I am going to take this and okay, so I'm going to take that position. I'm going to subtract 0.0000. No, maybe that's too much. All right, it's going to go fast either way. So transform matrix, and then what I need to do is update my constant buffer. I don't remember how to do that. I think it's like update sub resource or something like that. DirectX 12. Give me the 11 version. Ain't nobody using 12, brah. There we go. Sub resources. Update sub resource. Here we go. And that's done with the context. Okay, so after I calculate my new transform matrix, I'm going to use my D3D11 context to update sub resource. And the resource I'm going to update is my constant buffer. If I can find it. Vertex constant buffer. All right, I believe I need the address of that. The destination sub resource. A zero-based index that identifies the destination sub resource. Well, whenever I see zero-based, I think that means it's just, you can put 0 there. That's not true at all. Yes, and then a box if I want to specify how much or what specific area of that data I want to update, but I want to update it all. So I think I can just put a fat 0 there. And then the pointer to the source data in memory. So I think that is just simply an address to my transform matrix.m. Or not, just the actual matrix itself. And then source row, size of one row of the source data, the size of the depth of the source data. I feel like I don't need to actually tell it that. I think I could just put 0 and it'll just do the whole thing. I'll find out though. All right, so if this works, I'm gonna be so happy. All right, cannot convert argument 1 from a DD3 buffer. Oh, so maybe I don't need the address of it. Yeah, I don't. And I don't have a moving triangle, which is unfortunate. All right. Oh wait, yeah, maybe I do have to. One row, source data, size of the depth. Okay, so let's just say size of transform matrix. Nothing. Maybe it is working and that's just like really small. Hey. Bye, triangle. Yeah, okay, so apparently it's not going as fast as I thought it was. Probably because I have the VSync on. It's just going at 60 hertz based on my monitor. So just to make sure I'm not crazy, let's go ahead and do the opposite. See if it comes towards you. Oh, I just got hit in the face with a triangle. All right, cool. All right, what else can we do? don't really want to get too much further. I think I made some great progress. You know what I'm going to do just before wrapping it up? So I'm going to just do some really simple, really simple key inputs to allow me to move around using WASD. All right, let's see. How do I do this? Okay, let's make a bool array. I don't know, 128. Is it hparam? All right, so if the message is H, is it W? Is it always W prime? No, I don't feel like. Is it just message? Maybe it is W prime. No, that's not it. Okay. L-param, that's what it is. Duh. Heaven forbid you read the L-param. Still not working. The virtual key code of the nonsense. Repeat count scan. Is it just message? What if the, oops, what did I just do? The message is equal to that. Does that work? Nope. Left-hand operator, unless there is no acceptable conversion. Yeah, I don't think so. So what is MSG? So we got the W param, the L param. Is it message? There we go. Okay, so if the message is key down, then we want to check, actually no, so we want key inputs at message.w, actually, let me check here. Yeah, it is W param. msg.w param equals true. Then else if the message is key up, then we're going to set it to false. And we get, what is this? I guess warnings. 238. Oh yeah, I did need to use one equal sign. Cool, cool, cool. All right, so then to see if that's working, let's check if my key inputs VK escape. Yeah, all right, cool. So now I can use my key inputs array to tell which key is being pressed. So I can now do an if statement. So if key inputs at VKW, if that's true, then I want to go towards my triangle. So I'm going to take my model matrix and I'm going to take the Z coordinate and I want to add to it. Wait, no, I'm getting errors. Okay, VKW, undeclared identifier. Oh, what? Oh, what now? Where is my virtual key codes? VK. Oh. .057. So I probably should actually just make these then. All right, so define all right, this is gonna take a while. You know what? Okay, yeah, forget it. Do that next time. Define, yeah, that's right. Key W as 0x57. And then we will define key A as 0x41. And for OCD's sake, let's keep them alphabetical. Then S, or actually let's do D again. So 44. And then one more. So for key S is going to be 53. $255 missing equal sign. What? Oh, duh. I don't need an equal sign when I'm defining. I'm thinking a const. There we go. Oh my goodness, look at that. I'm moving towards a triangle. All right, let's do the other directions. And then I think I'm just gonna call it a night from there. All right, so when I move in the backwards direction, and right, okay, so for these two, I want to adjust the X position, which is here and here. And then so to go to the left, I want to subtract. Okay, yeah. Yeah, actually I had these backwards because it's the camera movement, not the object movement that I'm trying to do here. But yeah, all right, so I got a triangle that I can move around. Yeah, it's, I mean, super primitive right now because I could only move in one direction. I could only face in one direction. But yeah, next time I will do a lot more cool stuff. So I'm going to add quaternions so I can look in different angles, and then I can rotate things easier. I need to clean up a bunch of stuff. I need to be able to move both the model and a camera. So I'd probably just make a camera, like a data structure for a camera all together. But yeah, I'm in good shape. Making progress. I like it. Cool. So I'm going to again wrap it up here. Thank you for anybody who's been out there watching this. And I hope to see you next. Actually, before I go, let me go ahead and commit this. Add everything. Commit. We'll say it's a rudimentary math library. Started. I'll just say it's been started because obviously it's not done. And then we just want to push everything up there. All right, cool. Thanks again. See you next time.